Hello and welcome to a new video on IGCSE Physics Classified Paper 2. Today we will be covering the topic of electrostatics. We will begin with the topic of like and unlike charges. You should know that like charges repel and opposite charges attract. So in the first question, we're told diagram 1 shows two thin uncharged strips of plastic. Diagram 2 shows the same strips after they have been rubbed with a dry cloth. Which row describes the change on the stripes after rubbing and the force between the strips, after rubbing and the force between the strips after rubbing? So you can obviously see from diagram 2 that they have repelled. They have grown further apart. From this, we can infer that the force is a force of repulsion. So we can immediately neglect or cancel A and C. So to create repulsion, is the charge similar or opposite? We said that opposites attract, similars repel. So the correct choice here is choice D. Charge on the strips must have been the same. Two plastic rods P and Q are both negatively charged. Rod P hangs freely. The end of rod Q is brought near to end X of rod P and then near to end Y of rod P. What happens to the rods in each position? This is actually a very simple question. However, it could be tricky in the sense that you might be confused between charges and magnets. So with magnets, we have a north pole and a south pole. If you see rod P with X and Y, you might be inclined to feel that X and Y must be the opposite of each other, like north and south. But this isn't necessarily the case here. There are no poles. We just have charges. We're told that they are both negatively charged. So they must repel either way, whether it's brought near end X or end Y. We must see repulsion in both cases because they are both negatively charged rods. So the correct answer here is choice D. In the diagram, rod R hangs from an insulating thread. When the positively charged rod Q is brought close to rod R moves away from rod Q. What conclusion can be made from this observation? So moves away means repulsion. The two rods repel each other. In order to repel, they must be both positive. They must have the same charge. And since we know that Q is positive, we conclude that R must be positive as well. So the correct choice here is choice B. Moving on, we will now begin the topic of conductors and insulators. You should know that metals conduct electricity and non-metals insulate. A flexible electric cable consists of a central conductor and outer insulation. Of course, the outer layer must be an insulator so that if we touch the cable with our hands, we would not get an electric shock. So it is logical that the outer part is made of an insulating material, whereas since wires are used to transfer electricity in a sense, the central part must be a conductor, of course. So which of these choices are suitable for conductors and insulators? So let's cross out the wrong choices first. Plastic cannot be a conductor. Wood cannot be a conductor. Copper is not an insulator, of course, and lead is not an insulator. So which of these would work? Do we usually use copper or lead in creating wires? You should know that it's usually copper wires. And of course, the outer insulation cannot be made of wood. Have you ever seen wires made of wood? That doesn't make sense. So the correct choice here is choice A. The student tests the electrical conduction of four materials, aluminum, iron, plastic, and silver. Which materials conduct electricity? So the only insulator here is plastic. Everything else conducts. So aluminum, iron, and silver are conductors of electricity. So the correct choice here is choice A. Which material is a conductor of electricity? The metal. The metal here is brass. Glass, plastic, and wood are non-metals and they do not conduct electricity. Moving on, we will now begin the topic of electric fields. You should know that any field in general is a region in space where an object experiences a force. So what types of fields are we supposed to know? We have gravitational fields. We have electric. And we have magnetic. And which types of objects experience a force in each field? Gravitational fields affect any object that has a mass. Anything that has a mass experiences a force in a gravitational field. Electric fields affect objects that have charge. So any charged body will experience a force if it is placed in an electric field. Magnetic fields affect what we have previously described as ferrous metals. Ferrous metals are metals that are affected by magnetic forces. So you should distinguish between the three types of fields and understand that in general, a field is a region in which a force acts. Depending on the name of the field, we can discern which type of force acts specifically. What is an electric field? It's a region. Is it the region around the wire carrying an electric current in which a compass needle experiences a force? So compass needles experience force in magnetic fields. So this is incorrect. A region in which an electric charge experiences a force. This is correct. A region in which an electric charge is attracted by the Earth's gravity. No, this is called a gravitational field, and it has nothing to do with charge. It has to do with mass. A region through which electromagnetic radiation is passing. Again, this is not an electric field. So the correct choice here would be choice B. You should be able to identify the shape and direction of an electric field. So A and B are completely wrong. They sort of look similar to what a magnetic field could possibly look like, or specifically an electromagnetic field in a solenoid. But anyway, this is a topic for the future. This is not how an electric field would work. An electric field looks something similar to either C or D, but it moves from positive to negative. So the correct choice here is choice D. The diagrams each show a positive point charge. Which diagram represents the pattern and direction of the electric field due to the charge? Again, C and D are incorrect. They have something to do with the electric field due to a wire, but we will take this later in the topic of electromagnetics. Anyway, for A and B, they look like what we're looking for. They both look sort of like what we're looking for, but the difference is the field pointing out of the positive charge or into it? So the field should be pointing out of the positive charge. Had I had a negative charge, the field would have pointed inwards as such. So the correct choice here is choice A. So this is a similar question, but with negative charges. And we just said that for the negative charge, the field points inwards. So again, the correct choice here would be choice A. Our next topic is the transfer of charges. What you need to know about the transfer of charges is that positive charges are heavy. They do not move. Negative charges are the ones that move from one body to another. This is the main piece of information that you need to know. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What has happened to the rod? Like we just said, positive charges are heavy and they do not move, so you never gain or lose protons. You either gain or lose electrons. And since it has become positively charged, we can deduce that it has lost electrons. Hence, the correct choice here is choice C. A plastic rod is rubbed with a cotton cloth. This process causes the rod and the cloth to become charged. These charges cause a force between the rod and the cloth. Which row compares the charges on the rod and the cloth and describes the effect of the force between the rod and the cloth? So I have two things that are interacting, a rod and a cloth. In order for them to become charged, the charges or the electrons must move from one of them to the other. So they cannot both gain electrons and they cannot both lose electrons, because then where would the electrons come from, right? So one of them has to gain and one of them has to lose. So therefore, the charges on the rod and the cloth must be opposite. And we said before that opposites attract. So the correct answer here is choice A. A polythene rod is rubbed with a cloth. The rod becomes positively charged because of the movement of charged particles. Which row gives the name of these charged particles and the direction in which they move? Like we said before, protons do not move. So electrons are the correct answer. So it's either A or B. The rod becomes positively charged, which means that it lost electrons. Positively charged means it lost electrons. So the electrons move from the rod to the cloth, and the correct choice here would be choice B. A polythene rod is rubbed with a cloth. The rod and the cloth become charged as electrons move between them. The rod becomes negatively charged. Which diagram shows how the rod becomes negatively charged and the final charge on the cloth? Like we said, the electrons move from one body to the other. So if one of them is negatively charged, then the other one has to be positively charged, right? So I have to automatically neglect C and D. And where does from where do the electrons move? Well, they have to move from the material that became positively charged to the material that became negatively charged, because being negatively charged means it has more electrons than protons. So it must have gained electrons, right? So the electrons must have moved to it. Therefore, we settle on choice B. The electrons moved from the cloth to the rod. Hence, the rod became negatively charged and the cloth became positively charged. A student holds a rod in his hand. He rubs the rod with the cloth. The rod gains a positive charge. So gains a positive charge. This automatically tells me that the cloth now is negatively charged, which means that electrons moved from the hand, or from the rod, I mean, to the cloth. We have electrons moving from the rod to the cloth. The material of the rod must be an insulating material. So for transfer of charge to occur, we must have insulating material. So metals are neglected automatically, and the transfer of charge must be negative from the rod to the cloth. So the correct choice here would be choice C. Polythene rod is rubbed with a cloth. The rod becomes positively charged because of the movement of charged particles. Which row gives the name of these charged particles and the direction in which they move? So the rod becomes positively charged, which means that the cloth becomes negatively charged, which means that the electrons moved from the rod to the cloth. And like we said, protons do not move. So the charged particle moving is electrons, and the direction is from the rod to the cloth, which is choice B. A student holds a rod in his hand. He rubs the rod with a cloth. The rod gains a positive charge. So in this case, the rod is positively charged again, and the cloth is negatively charged, which tells us that the electrons moved from the rod to the cloth. And like we said, the material of the rod cannot be metal, it has to be plastic. This seems to be a repeated question. I'm sorry about that. So again, the choice here would be choice C. Plastic and electrons move from the rod to the cloth. A student investigates the electrostatic charges on three objects P, Q, and R. The student places object P on the insulated pan of a balance and notes the reading on the balance. The student then holds object Q a small distance above object P and notes the reading. Finally, the student holds object R a small distance above object P and notes the reading on the balance. The student's observations are shown. Which row gives charges that explain these observations? So object P has a mass of 86.5 grams, as we can see. Here, the total mass increased, which means that there is a downward force affecting P. Bear in mind that we are holding object Q and object R in place. We are holding them with our hands so they don't move. So object Q and R do not move, but object P will experience a force due to object Q, and it will also experience a force due to object R. We want to know the direction of these forces to make conclusions about the material or the charge of Q and R. So object Q pushes object P downwards, whereas in object R, we see that the mass decreased, so it's pulling object P up. So this is attraction, and this here is repulsion. So P and Q must have the same charge, and R must have the opposite charge. So we're looking for entries where P and Q are similar. So A and D are automatically neglected. For B and C, we need P and Q to be similar because they repel, but we need P and R to be opposites because they attract. So the correct choice must be choice C. Positive, positive, negative. B is incorrect because if they're all negative, then R would repel P as well, and we would get a higher reading than 86.5. So the correct choice is C. Finally, we move on to the topic of metal spheres. A negatively charged rod is held close to one side of a metal sphere. The other side of the sphere is Earth. Which diagram shows the distribution of charge on the metal sphere? So what do we expect to happen here? We have a negatively charged rod, and we have a metal sphere that is earthed. So we expect the positives to be attracted towards the left a little bit, and the negatives to be repelled towards the right. And since it's earthed, the negative electric charges, these guys, are going to flow through the cable to the earth. So what are we left with? We are left with positive charges only. And are they scattered around the sphere or pulled towards the left? Of course, they're pulled towards the left because the rod is negatively charged. So the correct choice here is choice D. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. What happens to the charges on the neutral sphere as the positive charged sphere is brought close to it? So a neutral sphere has the same number of protons and electrons, same number of positive and negative charges. What happens if I approach with positively charged sphere? We expect the electrons to be shifted towards the left, and the positive charges are heavy, so they don't really move. So the positive charges do not move, but some negative charges move to the left. A positively charged rod is held near to, but not touching, an uncharged metal sphere. The sphere is briefly now connected to Earth, and then the rod is removed. So let's draw the case here. So we have a rod that is positively charged, and we have a sphere. So what will the positive charges do to the sphere? Well, the electrons are all going to be pulled towards the left. The positive charges are going to remain in place, or maybe slightly attracted to the right, but either way, even if they do not move at all, the electrons will all move to the left, excuse me. And that tells us that the right-hand side of the sphere will have more positive charges than negative charges. Now, if I connect to the Earth, what happens? I have a very high concentration of positive charges here, and they will attract electrons from the Earth, which will move towards the sphere. So the sphere will attract electrons from the Earth because it has greater positive charge closer to the Earth wire. Now, I will remove the rod, and I want to know what is the charge on the sphere. So since it attracted electrons, it is now more negatively charged, right? Because you have more electrons than protons. Hence, the total charge is negative. So the correct choice here would be choice A. It is charged negatively because negative charges have moved from the Earth to the sphere. And the correct choice here would be choice A. And this concludes our video. Thank you for joining. I hope it was beneficial.